Hey Dimitri, where are you? Oh, I have to set the alarm before I go to bed or I shall be late for school tomorrow.
Hey, at what time will you set the alarm?
Now it's 11 pm. Well, I need to study for 2 hours and then I need to sleep. So I will set the alarm at 8 am.
Do you know you just used algebra to calculate the time for setting your alarm?
Not again. Don't say that. We use algebra in real life.
Okay, tell me for how many hours will you sleep if you set the alarm at 8 am from now?
7 hours?
But how did you perform the calculation? See, you used algebra without even knowing it.
Hello students, welcome to a brand new video of Notebook. So let me explain you how the calculation was performed by the boy. It was 11 pm when the boy decided to set the alarm. He set the alarm at 8 am, so the total time span is 9 hours. The boy had to study for 2 hours. If he slept for x hours, then x plus 2 is equal to 9, so x is equal to 7 hours. Students, in this video, we are going to start the chapter Algebraic Expressions and Identities. Algebra is the study of mathematical symbols. Students, does the word expression remind you of facial expression? But algebraic expressions are formed of variables and constants. What are variables and constants? A common real-life example of variable is the height of a growing plant, but the height of a lamppost is constant. In algebra, variables denote symbols whose values are not known. Generally, letters are used as variables. Most commonly used letters as variables are x, y, and z. In algebra, constants denote a fixed quantity. All the numbers are constants. Sometimes, letters may be used to designate constants. Using variables and constants, we can write infinite number of algebraic expressions. Some examples of algebraic expressions are x plus 8, y minus 5, 3x plus 2, 2xy, x square. Note the variables used in each of them. I hope all of you are familiar with the symbols used for addition, subtraction, multiplication, and division. In algebra, we call them operators. Now, consider the expression 3x plus 2. Here, the addition symbol is the operator. 3x and 2 are the terms of the expression. Take another example. Y square minus twice y plus 5. Here, y square, twice y, and 5 are the terms of the expression. The symbols plus and minus are the operators. So, an algebraic expression is composed of different terms. The terms are separated by operators. Terms themselves can be expressed as products of factors. Consider the example 4xy minus 3x plus 2y. Here the terms are 4xy, 3x and 2y. Now consider the term 4xy. It is the product of the factors 4, x and y. The numerical factor of a term is called coefficient. So 4 is the coefficient. Similarly, the term 3x is the product of the factors 3 and x. So 3 is the coefficient and x is the factor. Similarly, note the factor and coefficient of 2y. If the expression contains only one term, then the expression is called monomial. Examples 5x squared, 7xy, minus 12x. An expression containing two terms is called binomial. Examples x plus y, a squared plus 3b squared, 5xy minus 2. An expression containing three terms is called trinomial. Examples x plus y plus z, a squared plus 3b squared plus c, 5xy minus 2y plus 1. In general, an expression containing one or more term is called polynomial. Examples x squared, 3xy plus 5, a plus b plus c, x plus y plus w plus z, 5x plus 3y plus 2z minus x squared plus 1, and so on. Do you know that terms may be like or unlike? Like terms are terms that contain the same letter variables raised to the same power. Consider the examples 5a, 2a, and 3a. 3x squared, 12x squared, and 7x squared. 3xy, 5xy, 2xy, and 12xy. Obviously, if the terms are not like, then they are called unlike terms. Note some examples of unlike terms: 5a and 3x, 3x squared and 5y, 3xy and 12x. This was all about the keywords that you will encounter throughout this chapter. Students, it's time to end the video here. See you again in our next video. Till then, happy learning and goodbye.